Hey guys, welcome back. I welcome each and every one of you back. Hope you all doing well, and good morning, good afternoon, good evening, wherever you may be in the world. Welcome. And for those of you who just woke up and still gonna have a long day to go through, I strongly believe that your day is off to a fantastic start. I'm your author, the host, and the teacher of this lesson. You can call me Mr. T.O. Square, and without further ado, let's dive into it. So, we'll be starting with a new adventure here, a new lesson. We'll be going through the squares and the square roots. If you go back to the previous chapters that we have covered already, you see a lot of fantastic things, calculation that we have done, and the lessons that we went through, and I definitely hope you grasp each and every steps that we had to go through. So for today, we will be going through squares and square roots. We learn about square roots, how to calculate the square roots, how to be able to solve typically grade 10 different types of square roots. So probably why not advanced one as well. So yeah, we're gonna cover square roots, and the other thing is I wanted you to be able to understand the mission, the purpose attached to whatever we are doing, because the mission is to help students, to help professionals, to help pupil to be able to grasp the lesson before solving challenges that are given to them. So the thing is to allow students, to allow graduate, to allow each and everyone who's stuck somewhere in the field of mathematics to be able to find his way through, and to reach the other side with confidence, with determination, and with excellency. That's why we started this journey. So I believe that you will be the one who will be triumphant in the end. So yeah, the about the introductory, if you want to know mostly the whole concept of the services that we are providing. In the beginning, the first video, in that video that we created in the beginning, we step by step dissected the whole introductory, the whole process, the mission, the goal that we've set for this journey. If you want to know about it, just go watch the first video. You will be able to understand the mission attached to the journey that we've taken, and each and every step that we're looking forward to accomplish into this adventure. And the other thing is the coverage. So for the coverage, currently we are covering grade 10, then we're gonna go to grade 11, then grade 12, college, university. There will be a session for language, and we'll reach the decline to the professionals, engineering tools, software, lesson, mechanical, electrical, and further. So for today, for the moment, at this appointed time, we will mostly focus on the grade 10, and focusing the main subject of today's lesson is squares and square roots, which means in the field of mathematics. Then probably we'll jump to the field of physics. That's where we'll be from time to time orbiting. So yeah, the learning objectives. By the end of this session, every different attendees must be able to firstly refine the good practice and understanding of square roots operations. You have to be able to understand it, because if you don't understand it, you cannot solve it unless you understand it, then you will be able to solve it. So the understanding, the grasping of the lesson is the main focus, and I recommend that, to each and every one of you. Before solving challenges, be able to understand the method and the challenge itself, then there will be a good result, to the problem that you are solving. And familiarize yourself with the power square roots expressions, the solving process, the process of solving square roots. You must be able to acquire it, and familiarize yourself and be able to solve them accordingly. Grasping the simplification, expansion and factorization of square roots operations. Yeah, indeed, you must. It's a must. For those who are aiming to go further in their studies, this is the background. This is the debutant level. So getting it right at the moment will guarantee your future. So the fourth point, which is to be able to develop the ability to rewrite the square root expression without radical to the denominator. I know that on the fourth point, many people tend to skip it. Yes, many students that I've taught, in past years, it was very difficult for them to be able, to grasp this fourth point. But I'm here for that, because it's my purpose. It's the mission that I've taken upon myself, to convey the message, to convey knowledge to those who are looking for it. So we're gonna go through it, and I'm sure you will get it right. And the fifth point, which is a man stimulation. So I know that we still have calculators around us. We still have laptop computers that can help us solve different enigmas or problems. But your mind is the main calculator. Your mind is the main computer. Your mind is the main stimulus organ that will help you be able to come up with a refining solution. As long as you don't use it, let me tell you, you are missing a lot. So use your mind. And the last point, maintain a tangible analytic potential with regard to the training exercises. Be able to solve training exercises, because at the end of each and every chapter there will be a training exercising session. That's where you test if you were able to understand the lesson and you were able to grasp the deeper context of the lesson conveyed to you. So yeah, let's go for it now. So we're going to start with the different operations of square roots. The square roots of a positive number a is the positive number 1 squared gives you the same number a. So the square root is a positive number, meaning that it's greater to 0. It's never less to 0. It's always greater to 0. Any square root number, always never less than 0, always greater than 0. So note 1, you have, this is the symbolism of a square root. So you have this symbol here which looks like a musical note, and you have a positive number. I'm repeating, positive number. At this moment, at this grade, the a here substitute to a positive number, which makes the square root itself a positive number. So this square root here, this square root, the musical, symbol, and the a under the roof of this musical symbol, which is called the radical, because this is the radical. The symbol of the square root is called radical. The number, or let's say this a is the radicand, and the whole set is called radical. So the symbol here is called radical symbol. The number, or let's say the letter under the radical symbol is called the radicand, and the whole expression is called radical. So we have the radical symbol, we have the radicand here, and the whole expression is called radical. Don't confuse radical and radical symbol. So and we go ahead, it says that define here is the square root of a. So this symbol square root in a means is defined as square root of a. The root symbol, which is the musical symbol here, looks like a musical symbol, which is not. Looks like a musical symbol, is called the radical symbol. So you have the radical symbol here, and you have the radicand, which is the number or the positive number, and the whole set is called radical. For instance, we have square root of 9, which is 3. We have square root of 625, which is equal to 25. We have the square root of 121, which is equal to 11. We have the square root of 81, which is 9. And the square root of 144, which is 12. And finally, the square root of 6.25 or 6.25, which is equal to 2.5. So these expressions they call perfect square expression. We're gonna go through it, you understand. But for the moment, take them with a pinch of salt. Take them the way they are, and the way they are represented. If you want to memorize them, which is better, because it's going to help you. It's going to help you a lot. You will find that as we go along. So remember that the square root of a is uniquely defined if a is greater to 0. You may ask yourself a question. So what is the idea behind this line, behind the statement I just made? By that, let's take just a very typical example. We are here, so let's say square root of a equal b. So meaning that the example is right in front of you. So for each square root, there will be a number b attached to it as a result. Each and every time you're gonna have the square of a equal b, that will be equivalent. So that will be equivalent to a equal b square, meaning that if I make this number square, it's gonna give me the number a under the square root. So in general, it simply means that the square root of a is always greater and equal to 0. It's always positive. So the number of square roots at this grade up to grade 11 will remain positive. So you cannot have a square root, let's say square root of a -3, doesn't exist, or a square root of a -7. It cannot. There will never gonna be a square root written this way from this grade and the next grade. But when you reach grade 12 and upward, this is possible. It can work. You can solve it, but at this grade 12, you cannot solve a square root of a negative number. It is impossible. That's why this rule comes to play, that the square root of a is always greater and equal to 0, which is equivalent to square root of a. All square gives you a, meaning what? If I have, let's say for instance, a square root of 4, something like that, right? A square root of 4 gives me what? Gives me 2, right? But how did you get to this 2? To get to this 2, it's very simple. So we're just gonna do the same thing. The square root of 4 like this into bracket. If we make it square, or what happens? what you have to understand, and something you have to understand here is that the square root itself, the radical symbol, I'm gonna write it here. The radical symbol itself, it's equal to half. The radical symbol itself, it is equal to half. So meaning that if the radical symbol itself, it's equal to half, and the half of the radical divided by the exponent 2 gives you what? Gives you 1. And any number to the exponent of 1 gives you the same number. Right? That's why the square root of a square here gives you a. That's it. So the exponent, so this square root is an exponent. So the exponent of this square root, the radical symbol, it has a positive number, which is half. And because this half is an exponent, then we're going to have the exponent of the radical symbol multiplied by the exponent given to you, which is in this term here gives you 1, because half times 2 gives you 1, because 2 times 1 gives you 2, 2 divided by 2 gives you 1. Automatically we're gonna have 4 exponent 1, or any number to the exponent of 1 gives you the same number. That's why the square root of a square gives you a. So yeah, this is what you need to understand at this moment. You need to understand these things so that it's gonna be easy for you. If you do not, just feel free to shoot me a message or an email, then I will go back again with clear explanation. So by doing a little bit of recapitulation here. So the square root of a equal b. So each and every time you have a number under this square, under the radical symbol, there is a result attached to that number. To every operation there is a result, right? And each and every time you have the square root of a equal b, there will be an equivalent to a equal b square. I've explained how do you get to a equal b square, right? And the square root of a, it's always greater than equal to 0, which is the equivalent to square root of a the whole square, which gives you the radicand in this term a. There will be examples, we're going to go through them. I'm sure you will be able, to grasp, each and every one of them. So let me just wrap this off. Okay, let's get to it. So